Hello, everyone. Welcome to my channel. This is an educational channel. We focus on studying up on all kinds of different subjects that I think are underrepresented in our educational curriculum or not represented at all. In this case, pretty much not at all. This is a theory that has been mostly ridiculed by the scientific community, which is a very good indication that you might want to know something about it. We're studying right now, this is the 169th video that we've done on the reciprocal system of theory. And this is a theory that was derived by Dewey B. Larson back in the 20th century. And we're looking at his 1979 book called Nothing But Motion. The reciprocal system of theory basically states that we live in a universe of motion. The universe is not made out of matter. It's not made out of energy. It is made out of motion. Matter and energy are merely two different kinds of motion. And motion is the relationship between space and time. A relation that is a reciprocal relation. Space and time are basically components of a fraction that is motion. Space and time are basically what you would call opposites. They have the same qualities, but they are opposite components of a fraction. So space or time is the numerator of the fraction, and time or space is the denominator of a fraction in motion. But space and time both have their coordinate aspects, meaning that they both can come in 3 or more dimensions. And they both have their clock aspects, meaning that they both move in a scalar manner. That scalar motion is a motion that has a magnitude but has no direction. And Larson calls that clock space or clock time. The clock is always moving forward. Time is always getting later and later and later. And so too with space, space is always getting farther and farther and farther apart, but in no particular direction. And then space and time also have their discrete, they come in only discrete units. There's a minimum unit of time and a minimum unit of space. And there's nothing less than that within time or space. And 1 unit of space in 1 unit of time is the speed of light. The speed of light is basically the background or the origin of this universe. And half the universe is moving slower than the speed of light. Half is moving faster than the speed of light. I recognize that all of this seems to be pretty difficult, but what's really difficult is that you have to unlearn all of the scientific garbage that you've learned over the course of your life, from the pointy-headed, lab coat-wearing, arrogant guys that are working for the various universities and so on. I'm not saying that all of them are in on it, but the people that are at the top, they know that they're not telling you the truth. The ones that are really at the top of their field, they know that, okay, this is the best hypothesis we have right now. Things like the Big Bang or the black hole. These things don't exist. They are the best hypothesis that they have right now. When they are able to see their way out and see something better, they will grasp onto it. But that may take generations because the people that are in charge are vested. They have a vested interest in maintaining the current paradigm. And it's not until people who aren't vested kind of rise up and demand a change. See Thomas Kuhn's Structure of the Scientific Revolutions, for example. Okay, now we are in chapter 9 of this book that is called Rotational Combinations. For Larson, an atom or subatomic particle is a combination of motions. There are four basic kinds of motion. You have your translational motion, you have your vibrational motion, you have your rotational motion, and you have your rotational vibration. And then you have those in 1, 2, or 3 dimensions. And then you also have the combinations of motions, such as what we saw in the photon, where the photon, photon, according to Larson, is a combination of a rotational motion and a vibrational motion. So you get this vibrational motion, but it's also rotating in this, so you end up with a sine wave or a simple harmonic motion. One of Larson's followers eventually amended that, and he came up with the idea of a birotation. So a photon is a birotation. You have two counter rotations, and when you combine those two, the resultant is also a simple harmonic motion. But now he's getting beyond the photon, and we're talking about the what he calls rotational combinations. So we'll start right here. This present chapter will initiate a demonstration that the very complex mathematical relations that are encountered in many physical areas are the result of permutations and combinations of simple basic elements, rather than a reflection of a complex fundamental reality. The process whereby the compound unit of motion that we call an atom is produced by applying a rotational motion to a previously existing vibrational motion. The photon is typical of the manner in which the complex phenomena of the universe are built from simple foundations. Okay, so I think I was wrong on that. I was Larson's saying that you have a translational motion, and you have a vibrational motion. When you combine those two, that's where you get the simple harmonic motion. His followers basically have rejected that idea in favor of the birotational model, which seems to at least answer more questions. Okay, so the process whereby the compound unit of motion that we call an atom is produced by applying a rotational motion to a previously existing vibrational motion, the photon, is typical of the manner in which complex phenomena of the universe are built up from simple foundations. Okay, so Larson is really saying that there is this photon already. You already have the photon, and then you're adding motions to that photon, and that's how you get to the atom. Now, when you're looking at this, where you say that the speed of light is the midpoint of the universe, or the background, you're talking about the speed of light in all directions. That's what Larson calls the progression of the natural reference system, a scalar motion outward. Now, that scalar motion outward, you can think of that as really anti-gravity. It's 3 dimensions of anti-gravity. And so you need to have 3 dimensions of gravity to cancel that out. Or so the photon is one of those dimensions of gravity that is canceled out. Now you have to have 2 more to cancel out the progression of the natural reference system. Okay. We start with a uniform linear or translational motion at unit speed. Then, by directional reversals, we produce a simple harmonic motion or vibration. That's the photon. Next, the vibrating unit is caused to rotate. The addition of this motion of a different type alters the behavior of the unit, gives it different properties, as we say, and puts it into a new physical category. All of the more complex physical entities with which we will deal in the subsequent pages are similarly built up by compounding the simpler motions. The first phase of this mathematical development is a striking example of the way in which a few very simple mathematical premises quickly proliferate into a large number and variety of mathematical consequences. The development will begin with nothing more than the series of cardinal numbers and the geometry of 3 dimensions. By subjecting these to simple mathematical processes, the applicability of which to the physical universe of motion is specified in the fundamental postulates, the combinations of rotational motions that can exist in the theoretical universe will be ascertained. It will then be shown that these rotational combinations that theoretically can exist can be individually identified with the atoms of the chemical elements and subatomic particles that are observed to exist in the physical universe. A unique group of numbers representing the different rotational components will be derived for each of these combinations. The set of numbers applying to each element or type of particle theoretically determines the properties of that substance, inasmuch as these properties, like all other quantitative features of a universe of motion, are functions of the magnitudes of the motions that constitute the material substances. It will be shown in this and the following chapter that this theoretical assertion is valid for some of the simpler properties, including those which depend upon the position of the element in the periodic table. The application of these numerical factors to other properties will be discussed from time to time as consideration of these other properties is undertaken later in the development. One preliminary step that will have to be taken is to revise present measurement procedures and units in order to accommodate them to the natural moving system of reference. Because of the status of unity as the natural reference datum, a deviation of n-1 units downward from unity to a speed 1 over n has the same natural magnitude as a deviation of n minus units upward to a speed of n over 1, even though when measured from 0 speed in the conventional manner, the changes are wholly disproportionate. When n is 4, for example, the upward change is from 1 to 4, an increase in 3 units, whereas the downward change is from 1 to 1/4, a decrease of only 3/4 of a unit. Okay, now this is just the reciprocal system. The reciprocal is basically a multiplicative system rather than an additive system. So when you have a stationary reference system, you're just adding and subtracting. Say you start with 0, and then you have a speed of 1, that's plus 1. And then you have a speed of -1, that would be -1. But if you start with already with a natural reference system where the datum, or the place that you're making the reference point that you're making your references from, is already outward at 1 unit, then you're using multiplicative inverse and its inverse division. You're using fractions. So if you, it's just like exactly what he's saying here. Um, if you're using this natural reference system, you're using multiplication. So when you go from one unit, if you add one, then you go to 2 units. But if you go in the other direction, you don't go to 0, which is what you would do if you were subtracting. You go to 1/2 of a unit. That's a reciprocal. The reciprocal of 2 is 1/2. So you're using reciprocals, not addition and subtraction. So that's really what you have to understand when you're doing this, is you're basically using multiplication and division rather than addition and subtraction. So if you're using addition and subtraction, you have a midpoint of 0, and you have plus 1 would be 1 and minus 1 would be -1. But if you're using a reciprocal system and a natural moving system of reference, then you have 1 as really the 0 point, or 1 as the center, and plus 1 would be 2. But -1 would not be 0, it would be 1/2. And then you move 1 further over, you get to 3, and the difference wouldn't be, that's a difference of 2. The other side wouldn't be -1, it would be 1/3. Okay, and so that's what he's saying. When n is 4, for example, the upward change is from 1 to 4, an increase of 3 units, whereas the downward change is from 1 to 1/4, a decrease of only 3/4 of a unit. But really, that's in a reciprocal notation, that downward change from 1 to 1/4 is -3. Okay, that's what you do, is you really subtract the denominator from 1/1 to 1/4. In the same way that you would use that for the numerator on the other side, from 1 to 1/1 to 4/1. Okay, so that's kind of the main adjustment that you have to make when you posit the idea of a universe of motion. If the universe is already in motion, if there exists motion without anything moving, then motion is the background, the origin, the contents of the universe. And so you need to adjust to using a fractional or reciprocal or multiplicative standard when you're adding or subtracting from that reference point. Okay, in order to reflect the fact that these deviations are actually equal in magnitude from the natural standpoint, the basis on which the fundamental processes of the universe take place, it is necessary to set up a new system of speed measurements in which we express the magnitude of the speed in terms of the deviation upward or downward from unit speed, instead of measuring from some 0 in the conventional manner. Inasmuch as the units in which speeds are measured on this basis are not commensurable with those of speed as measured from 0, it would lead to complete confusion if the units of the new system were called units of speed. For this reason, when reference is made to speed in terms of its natural magnitude in any of the publications dealing with the reciprocal system of theory, it is not called speed. Instead, the term speed displacement is used. The units of this displacement being natural units of deviation from unity. Okay, so that is the term that Larson has chosen to express the speed displacement. And I think it's a pretty good term, but it can be kind of confusing. Again, when Larson's kind of coming up with this entirely new paradigm for how you're doing science, he has to come up with a new vocabulary, a new lexicon for these for the various things that he's trying to express. He has to come up with words, and in some cases, the words that he came up with work better than other words that he's using. So sometimes the terminology that Larson uses is a little bit awkward, but in this case, I think that speed displacement does actually work fairly well. Okay, one more paragraph here. In practice, the term speed displacement is usually shortened to displacement. And this has led to some criticism of the terminology on the ground that displacement already has other scientific meanings. But it is highly desirable as an aid to understanding that the idea of a deviation from a norm should be clearly indicated in the language that is used. And there are not many English words that meet the requirements. Under the circumstances, displacement appears to be the best choice. The sense in which this term is used will almost always be indicated by the context in which it appears. And in the few cases where there might be some question, the possibility of confusion can be avoided by employing the full name, speed displacement. Okay, we'll leave it there. We'll come back maybe tomorrow, even discuss some of this terminology, but we will start again with this next paragraph when we come back. Have a great day, and thanks for tuning in.